So now we have a talk by Aitor Arrieta regarding design operation continuum methods for traffic master.
Yeah, okay, thank you for the introduction. My name is Aitor Arrieta. I'm a lecturer and researcher at Mondragon University, but I closely collaborate with Orona, which is an elevators company. So within Orona, I'm inside the traffic master team, where we develop dispatching algorithms and the technology for allocating the elevators to each calls. And here we have some data from 2020 and 2021. In total, we made like 100 and almost 200 modifications, each of these involving changes in several lines of code and different files. We also had 10 different development versions and different branches and so on to incorporate to these algorithms new functionalities, correction of bugs, integration with communication libraries for dealing with hardware obsolescence, and so on. So what we wanted to do is, after when we have these changes and so on, accelerate and somehow systematically validate and deploy new versions of these algorithms, and also monitor the effect that these changes have in the real installations. So currently, before this project began, the life cycle of these changes were, okay, sorry, I'm a developer, I want to develop a new function, or I want to correct a bug, or and so on. So I basically program this. When I have a first version, I make some functional validation using Elevate, which is an elevator simulators. And what we do here, we semi-manually execute different tests, and later we have different logs that we need to assess, usually manually, also the CSV files that Elevate provides, and so on. Once that we have a first version validated in Elevate, what we do is incorporate these changes to the real hardware, where we have the dispatcher, whereas all the mechanical and electrical parts of the elevator are emulated into a hardware in the loop test bench, performing this way a real-time simulation. And finally, once that we validate this simulation, this version in the hardware in the loop simulation, what we do is go to the real installation and update the traffic dispatching algorithm. As you see in all these 4 steps in the life cycle of a change, there are many manual processes, and many actors are involved. So what we have carried out through the Adeptness project, which is an H2020 project, is to provide first solution to automatically test and validate new software versions using simulation, and this way automatically detect bugs and anomaly before the software is in production. The second thing we wanted to do is, okay, somehow analyze the impact of these changes in the installation. So for that, we had to remotely monitor the system. And what we also wanted to do is automatically update and deploy the new versions, both in the installation as well as in our personal computers and in the hardware in the loop test benches. So for the case of the automatic detection of bugs, what we developed was a requirement specification language through a domain-specific language, in which we modeled each requirement with an easy interface, as we can see here. With this, what we do is automatically generate what we call oracles. Oracles are software components that automatically verify whether the system is behaving as expected or not. And with these oracles, what we do is generate the code and pack it into a Docker microservice and deploy it wherever we want. This can be either in our personal computer, this way communicating the Elevate simulator with this microservice, in the hardware in the loop test bench, or directly in operation. As for remote monitoring, what we do is publish the different variables of interest in the cloud through an MQTT protocol. And to do that, what we have developed on the one hand is what we call a trace library, where the code that of the dispatcher can be manually modified with this library. And what it does is publish different data following the SNML protocol. We do the same with a CAN monitor in Orona. The communication protocol that is standardized to communicate among the different CPUs that they have is CAN. So what we do is develop a small monitor that can read the different data frames and publish in the same format through MQTT in the cloud. With this, what we can do is monitor different variables through, for instance, here we have Grafana from the laboratory, and this can be done either for Elevate simulators, and the hardware in the loop test bench, or an installation. And these variables are also, well, the test oracles consume these variables to decide whether the system is behaving correctly or not. And finally, what we do is remotely update a new software version. To do that, what we do is select the new version to be deployed. We also need to select the microservice and the microservices and the different test oracles that are going to test and validate that version in either in operation or in simulation. And we remotely and automatically deploy this version. This can be, as I previously said, either in the personal computer in Windows or in the real dispatcher. So on the one hand, this provides three key benefits. From the deployment perspective, we have an effort saving, we save effort, definitely, because we don't need to manually deploy different versions. And also we save speed, because we don't need to send a maintainer to the installation to update the new version. With monitoring, we increase the awareness in an installation, and eventually we can also derive the different data that is necessary to extract the passenger flow in a building and reproduce these situations in Elevate or in the hardware in the loop test bench. And in relation to validation, we have here automation. So we can execute as many test cases as we want, and this enables us to detect faults faster and have less bugs in production. With this, we have the first adeptness prototype, where we have been able to automate the execution of tests both in simulation with Elevate as well as in a hardware in the loop test bench. We could also remotely monitor the different variables of these tests and so on. And we were able to, our initial prototype already automatically deploys new software versions in a Windows operating system as well as in the dispatcher. It's not worth it to mention that this is a research project of a very low TRL, and we have been experimenting with the traffic dispatching algorithm, but it can also be extended to other aspects of the elevator. If you are interested in this work, you can visit the website of this European project named Adernes, and you can find there the different requirements, architecture that we have used to carry out this, and so on. So this is all. Thank you for your attention, and if you have any question, let me know.